Alright, so today in 7.7 we're going to look at finding inverses and also graphing those. There's really one main concept you need to get, and if you get this down, it makes everything else pretty straightforward. Because this same concept is going to be true with inverses, whether you're talking about an inverse in a list of points like I have up here at the moment, whether you're talking about inverses in an equation, or whether you're talking about inverses on a graph. The main idea is going to be the same. Here's the main idea. The main idea is you take your x value and your y value and switch them, swap them. If you can do that, you're going to get the inverses down. It's just going to be about number crunching. So if I've got this list of points, if I wanted its inverse, I would just switch it. So here the x is -1, the y is +1. I would just switch those to get the inverse. Same thing on the rest of them. Now, what I want y'all to see is what this looks like on a graph. So I'm going to go through and graph these two sets of points, and I just want to do it in different colors so that you can see them in comparison. So I'm going to put this first one in blue. So -1, 1, 0, 2, 1, 3, and 1, 4. Now technically this is not a function. You'll see it fails the vertical line test. Okay, second one I'm just going to put here in red. I have 1, -1, 2, 0, 3, 1, 4, 1. Now I want y'all to look at those. See how they're kind of like reflections of each other? If I were to put the line y equals x, now y equals x, think about y equals mx plus b form. It's like y equals x plus 0, y-intercept of 0, slope of 1. I'm going to put this line up here. See how they're reflections of each other? That's what inverses are, is they're just reflections of each other over the line y equals x. That's all. So you should see that if you're doing something on an equation, on a graph, when you switch the x and the y, they'll be reflections of each other over that line right here, that dotted line I put on here. So if you're graphing it, you're going to notice that. All right, so if it's points, switch the x and the y. Equations, we're going to do next, switch the x and the y. That's the main idea with the inverses. All right. So let's do an equation. So I have y equals 3x minus 10. Now sometimes it'll be written as f of x. If it's written as an f of x, just change it to a y. And we want to find the inverse. All right, so remember, take the x and the y and switch them. All right, so I'm going to add the 10 and divide by the 3. So once I go through and I switch the x and the y, then go back and solve for that y value. All right, so I have y equals 1/3 x plus 10 over 3. I think I'll write that as 3 1/3. Okay, now just for the sake of writing it in the form we normally have it in, I'm going to go back and put my y first. So these two are inverses of each other. Now I want to just show you a little bit with notation. If this was f of x here, this one right here would be called f to the -1 of x. This -1 exponent is your symbol for inverses. So if you've got an f of x, the inverse of it would be f to the -1 of x. If this were a g of x, this would be g to the -1 of x. They're inverses of each other, so they use the same function name. The -1 denotes that it's the inverse. Okay, one more of these. All right, so right here, I have y equals x squared plus 3, and I want us to find its inverse. So remember, you're going to switch the x and the y. So you'll notice here, I just switched the actual x and the y. I just swapped those two. And then I'm going to go back and I'm going to solve. So I'll have x minus 3 equals y squared, solve for the y, and take the square root. Now make sure when you take the square root you do a plus or a minus. Okay, so again, let me put the y first. Now I want us to just think about this for a second. Just make sure that this kind of makes sense. If this is a x squared equation, and it is, then it's going to be a parabola. I don't have a perfect parabola, but there's one for us to look at. That's in blue. Now, if you're talking about square root of x looks like that. Negative square root of x is the bottom part of it. See how they're reflections of each other? Inverses are always going to be reflections of each other. Now we haven't graphed the square roots much, so I'm just kind of letting you know that. But now I asked you one more question here. I asked you if the inverse was a function. Now this was my original. It is a function. It passes vertical line test. But if you look at the inverse, it fails vertical line test. No, it's not a function. Okay, and then the last thing we're going to do today is we're going to go through and just decide if two things are functions of each other. Now, just so y'all kind of know this, I'm going to give you the general idea here, and we're going to look at a pretty simple problem. The computation can get a little bit heavy on these, so you'll see on some of the homework problems the computation's a little bit heavy. I want y'all to really work on getting those because it's just a computation thing. We'll probably do a few of them in class though, so that you'll get a little bit more practice, but I want you to try them first because you really do have to kind of work through some of your own stuff on your own. I want you to do that some on your own. All right, so I gave you a definition here. Now, I just want to tell you the bottom line. Remember, the f to the negative 1 is the inverse. See how I have those composition symbols from I think it was from yesterday, 7.6. The composition symbol means we're doing the plugging in stuff. Now, here's what these mean. If you go through and you do a composition with the two functions that I give you, if they simplify down to x going both directions, then they are inverses of each other. If they don't simplify down to x, they're not inverses of each other. Okay, now let me give you a little example. Now, like I said, we're only going to do one little example. You'll have some bigger ones in your homework. We'll probably do some together in class. If I go through and I do my compositions, so I'm going to do them both directions, if these simplify down to x, they're inverses of each other. If they don't, or if one of them doesn't, they're not. All right, so I have 5 times x, that's my f of x, and then in for the x, I'm going to plug in the g. Okay, so x over 5. So the 5's will cancel. All right, so this one, so far so good. All right, let's check over here. Here I'm going to start with the g of x. And then in for my x, I'm going to plug in my f. So I'll have 5x over 5. So this one checks out. So yes, they are inverses of each other. Now remember, if it does not simplify down to x, they are not inverses of each other. So it's possible that it doesn't work out. You're just checking to see if they are or if they're not. All right, so that is 7.7.